Today, we will introduce financial and economical analysis for energy investments. So, until now, we have seen different strategies for energy efficient strategies in buildings, and we have developed techniques to simulate energy in buildings, or also, let's say, if we use ANSYS Fluent or Energy Plus, depending on the application. Now, what we will do, we will develop economical tool in order to assess the viability of a project. So whenever we suggest, let's say, to use a certain system, we should invest it on the economical level also, because it's not enough to reduce energy consumption. We should also reduce the cost whenever we select a certain option. So the financial analysis or economical analysis will help us into deciding which alternative to select between several ones that we are studying. Now, in this chapter, we'll focus on the common and different features between economic and financial analysis to know in which case we should, let's say, use a project on in the private sector or in the public sector, depending on the result of the analysis we do. So to start with, we know that the energy sector puts major demand on limited and competing investment funds. The basic analytical frameworks used to evaluate energy projects will be the financial appraisal and cost-benefit analysis. We'll see what is the difference between the two, and this will help us into deciding on the owner of the project, if it should be, let's say, the country, or if we should have private investors. So whenever we talk about financial appraisal, we have private investments, and we'll cover in detail how to calculate financial cost and benefits. While if we want to consider investment with public or near public characteristics, then we should conduct the cost benefit analysis that will be developed in another lecture. Now, the two methods, and economical one, share several common features. First, we know that one of the main disadvantages of energy projects is that they are capital intensive. We already discussed that whenever we use renewable energy, the main cost that we should put will be at the beginning of the investment. So, for example, if you consider, let's say, if you want to produce electricity from water energy, you need to construct a dam, and you need to put a high budget at the beginning of your project before having any benefit from it. So, and you might need a large period of time in order to having your money back. This is why we say that energy projects are in general capital intensive, since they will require a high amount of money at the beginning of the project, which makes them risky a little bit. So energy projects tend to be capital intensive as the initial investment requirement is often high. For example, if you consider the electricity industry, it tends to be 2 to 3 times more capital intensive since we have a high initial investment requirements. Plus, the manufacturing industry, and if we compare this to the manufacturing industry, it will represent a much higher capital in case we take the electricity industry, which can rely on renewable energy. Similarly, if we consider also fossil fuel, if you want to extract fossil fuel to use them, it is also capital intensive. So if we want to talk about renewable energy, or if you want to use fuel to produce energy, both now are capital intensive. The first one, because as we mentioned, renewable energy projects will need a high capital at the beginning. And currently, if we are talking about fossil fuel, the extraction of them is becoming more and more challenging and will cost a lot. If we go backward 10 years, fuel extraction cost was really small. This is why from 20, let's say, years, no one invested in renewable energy, because the fuel cost was really low. However, now with the high cost of fuel extraction, we are shifting towards renewable energy, despite that the investment is high at the beginning. And always, we can, if we see the advanced with the variation of use of renewable energy with time, we can see that in a developed country it started a long time ago compared to developed countries, because for developed countries it's not easy to have this high cost and build the energy project relying on renewable energy. Now, another disadvantage of energy project is the asset specificity. So, in general, whenever we talk about energy project, uh, they are used, if you want, in limited alternatives. So, the assets of the energy industry will tend to have a high degree of specificity. This means that they do not have alternative uses other than their use in the energy sector. This specificity makes them more risky, because let's say you have a product that can be used in several ways. In case you have a problem on one level, you can use it in another way. However, when we talk about in general energy projects, they are mainly used to produce energy, and we cannot use them somewhere else. Another issue also is the long life of assets. So most energy investments live long. For example, if we want to consider uh, a power plant that can will operate for 25 years, or a hydropower plant can live 50 years. So even for the most simple case, which is a diesel plant, it will operate for more than 10 years. So because we have a long lifetime, this will increase the uncertainty of the project, because whenever you want to study the economical aspect, you need to take into consideration a time effect, what will happen after, you don't know what will happen after 10 years. You might have a lot of risks that you are not aware of. That's why we should take care when we take into consideration long life projects. Now, uh, another issue related to energy project is that take longer to build. For example, before starting to have productivity, you need to wait a large time. So, for example, a nuclear power plant can take 8 to 10 years to construct, and a dam can also take such a long period. Even relatively faster gas plants can take 2 years to build. So you have to wait a long period of time before you can start really with having production from your system. And any changes in the business environment during the construction could present high risk to the investment. So this requires